All right, so I'm sorry if you started watching the other video. I forgot that I had changed this so much. So in class, let's just go over like where we were in class on this problem here that we were doing. And so here we go. So in class, we had gotten this far. We had graphed this little square and noticed that it wasn't lined up, and it wasn't lined up this way either. And so they gave us our transformation equations. And so in class, we had gone this far. We had our equations for the four sides, and we got v equals 0, u equals 0, v equals 1, and then finally u equals 1. So I'm going to pick up right there because that's where we are. So those three things. So that was basically steps like 2 and 3. Step 2 and 3 basically describe this area. With my u and my v, it describes an area between u equals 0 to 1 and v equals 0 to 1. So that ugly square that was up top, that was all like, you know, like crooked and kind of like not lined up, I can now emulate it with this square right here. So when I do my double integral, I'll just be going du 0 to 1 and dv 0 to 1. Okay, so but I do have to find my Jacobian to put out front, maybe if it's just a number, and I also have to replace this x plus y. Right. So step 4, I got to do the Jacobian. So for my Jacobian, I set up a determinant. I have to do the derivative of x with respect to u, so that would be 2. The derivative of x with respect to v, so it'd be 3. Now y with respect to u is 3, and y with respect to v is negative 2. So I get negative 4 minus 9, so that's negative 13. And remember, I take the absolute value, so it's 13. So there's going to be a 13 in front of here. So now we're going to start setting up our integral. You can see I have a 13. It's a number, so I put outside 0 to 1, 0 to 1. Now x plus y is supposed to be what I'm taking the integral of. So here's x and here's y, because remember I need all u's and v's. So if I add these together, I get 5u plus v for my integral. So if I do this integral, that would be the same answer as the integral of the thing that we had up here earlier as doing this one over this region here. And so, you know, all this work, by this time you might have been able to just do this one, but you know, who knows. All right, so let's do this guy. With respect to u of this one, that's going to be 5u squared over 2 plus vu, plugging in 0 to 1. So luckily 0 is not going to do anything, so I'm going to put a 1 in. So I get 5 halves plus 1v minus nothing. So now I have the integral with 13, 0 to 1 of 5 halves plus v and dv. So I will get 5 halves v plus v squared over 2 from 0 to 1, and I still do have to multiply this all by 13. So plug in 1, I get 5 halves plus 1 half. All right, plug in 0 is 0, so I'm basically getting 6 halves, which is 3. So 3 times 13, so that's 39 is my result. Okay. All right, so let's check out this guy. So in this one, let me see if I have, oh yeah, so this picture up here, so I've done step 1 for you right here. So here's step 1. All right, so in color, it's a little bit easier to see. So this little region is what I'm trying to integrate over, and that's all these little, xy equals 1, xy equals 2, xy squared equals 1, and xy squared equals 2. So this, naming these 4 things, like names this little space inside here. All right, and so you see that is going to be hard to write an integral for because the tops and bottoms don't line up. So like if I wanted to split this up, I'd have to like kind of split it into a couple places, and there'd be different top and bottom for each little piece. Okay, so it'd be kind of hard to do if I didn't do it what we're about to do. All right, so that's step 1. Step 2 and 3. So in this problem, I'm given an equation for u is xy and v is xy squared. So this time I'm given equations for u and v. Last time I was given equations for x and y. So depending on which way you're given the transformation equations, you have to go and find the other ones. Like if you're given uv, you got to find xy. If you're given xy, you got to find uv. All right, so we are going to, let's see, try to mesh these together. I needed an equation for x and y in terms of u and v. So I am going to say this. Let's see. Would you realize that this is x times y times y? All right, so that's v, right? So xy is equal to u. So I'm going to replace a u right there. So uy is equal to v. So that means that y is just v over u. So there's one equation. So now I think I will take that information and put it here. U equals x, y is v over u. So that way, when I move this to the other side, I'll get u squared over v. And there I go, my equation for x. Okay? All right. So, because I need these to do my Jacobian, I need to do dx du and dx dv. Okay. All right, so let's map out our problems. I have xy equals 1, xy equals 2. Those are my boundaries of this shape. Then I have xy squared equals 1 and xy squared equals 2. Well, look how convenient. U is xy. So this means that u equals 1. And this means that u equals 2. Xy squared is 1. Oh, sorry. V is xy squared. So this means v equals 1. And this means v equals 2. So I have this region, u and v, from 1 to 2. 1 to 2. Okay. All right. So then I can go ahead, and it's going to be like a little box right here. So it's a much easier thing to do an integral over. So step 4, let's find our Jacobian. So my Jacobian is going to be the derivative of x with respect to u. So it's going to be 2u with a v on the bottom. Now the derivative with respect to v, I'm going to have to rewrite that. If I write it as u squared v to the negative 1, then I can just do the derivative with respect to v is negative 1, u squared stays, v to the negative 2. So negative u squared v to the negative 2. Now the derivative of y with respect to u, so I think I'm going to write that over as v and u to the negative 1. The derivative with respect to u will be negative 1 v u to the negative 2. So negative v u to the negative 2. And the derivative with respect to v will be just 1 u to the negative 1. All right, so I'm going to multiply these two. So 2u over v times u to the negative 1 minus the multiplication of these two. So v u to the negative 2 times u to the negative 2, I'm sorry, u to the positive 2 and v to the negative 2. All right, so let's see. So let's clean this up. These cancel, and I basically have 2 over v. Over here, let's see, these cancel, and 1 and negative 2, this turns into 1 over v. So 2 over v minus 1 over v is 1 over v, is my, what's it called, my Jacobian. All right, so since that has a letter in it, the Jacobian cannot go outside the integral, it has to go inside. So let's do my integral now. So I have a double integral, I'm going from 1 to 2 in each direction. So 1 to 2, 1 to 2, and I have du and dv. And let's see, I got y squared. So y squared is going to be, let's see, y was v over u. So that's going to be v squared over u squared. And remember, I'm going to put my Jacobian of 1 over v. All right, so that cleans up to be v over u squared. So I think what I'd like to do, since these are all numbers, and this is going to get kind of gross, let's separate it. All right, an integral from 1 to 2, two integrals, 1 to 2. I have du and dv. So why don't we, this is my expression, so my v is going to have a v. This is going to be u, 1 over u squared, so u to the negative 2. All right, so u to the negative 2, I am going to get u to the negative 1 over negative 1 from 1 to 2. So that's basically just negative 1 over u from 1 to 2. So it's going to be negative 1/2 minus a minus, so plus 1. So that's going to be 1/2. And this guy here is going to be v squared over 2. from 1 to 2. So it's going to be 4 over 2, which is 2 minus 1/2. So that's 1.5, so 3/2. So if I multiply hello? Yes. Oh. She got it. Yeah, she found it. Yeah, she came back and got it. So I couldn't I couldn't get a hold of anybody, and I was like, ah, but she came by. That's okay. Yeah. All right. Thanks. Bye-bye. All right, sorry about that. My phone was ringing, I didn't know. All right, so anyway, I have to multiply these two answers. So 1/2 and 3/2 multiplies to 3/4. And that is our answer. Okay. All right, so you could stop watching now and go do your two problems. Or if you want to stick around, I will show you example 3 and example 4 if you want. Okay, so I think I'm just going to show you basically like with what I have already done here and kind of cover it up and show you as I go. All right, so anyway, pause the video if you want, if you don't want to watch anymore. All right, so let me see. Let me get a piece of paper to cover up with. All right, so here's our information being given. I want to do this integral over a region that's kind of like a trapezoid shape. So if you graph all these 4 points, it's basically going to look like this. All right, a little trapezoid shape. So if you're going to do this double integral, you probably have to like draw a line down here, and you'd have to do this section and do that section, do 2 separate sections, and you had to do a double integral, so 2 different double integrals. So that's why it's advantageous to do a substitution. Okay, so I found the 4 corners, or the four lines for my region, and then I have to go ahead and find some replacements. Now they've given me u equals and v equals. So I have to solve for x and y, right, and get equations for those. But first of all, I took y equals x minus 1, and I said to myself, well, actually I found my equations first. So I said to myself, well, u equals and v equals, so I saw that the y was going to cancel when I added, so I went ahead and added. I got u plus v equals 2x. So that means x is a half of each of those. So I got that. And then over here, once I had x, I plugged that into, it looks like this equation here for x. So I had u equals that x plus y, and I went ahead and brought everything over to the left to solve for y. So there's my 2 equations for x and y. So every time I see an x and y, I can put these 2 things. All right. So then I went on to getting equations for these 4 sides. Okay. So y equals x minus 1. So I took x and I took away 1. I cleaned that up and got v equals 1. Then y equals x minus 2. So I took y, then x minus 2, cleaned that up, got v equals 2. Then x equals 0 and y equals 0. When I cleaned those up, when I had x, so right here, equals 0, I got u equals negative v. And if I set y, this part, equal to 0, I ended up getting u equals v. Okay, so these were my 4 things. V equals 1, v equals 2, and then u equals negative v and u equals v. So that created this shape right here. So I could go from this side to that side, and then this side number to that number. So I could go from u equals negative v to u equals v. So that's what I did right here. And then I went from 1 to 2. 1 to 2. So that's my integral right there. Okay, so then my Jacobian. My derivative of x with respect to u is 1/2. With respect to v is also 1/2. Then y with respect to u is 1/2. Y with respect to v is negative 1/2. So I did my crisscross. It came out to 1/2 as well. So that 1/2 is going in front of this integral I've set up. And the only thing I have left to show you is that this part right here. So I have u over v. Well, u over v, you see how u was x plus y and v was x minus y, so that's how I got u over v right there. And so it might be more advantageous to write this as u times v to the negative 1, but we'll see in a second. All right, so here's my integral I have to do. So I was doing with respect to u first. So I knew that v didn't really matter to me, but it was going to still create some kind of like reaction when I was doing my integral. So I imagined to myself, what